I'm E2 Whitmore.
I'm E2 Ward.
And this is a supplemental video tutorial for electronics technician rating performance qualifications.
You can complete this RPQ in 4 easy steps. Step 1, gather your test equipment and your documentation. Step 2, perform your resistance measurement. We're going to be doing that with a megger. Step 3, performing TDR measurements. Step 4, documenting your results.
To complete this RPQ, you will need to gather the following test equipment and review the following documentation. You will need a megger, a TDR, the TDR job aid, megger job aid, NEATS Module 21, and you will need to fill out the Navc 9210/19. To complete step 2 of this RPQ, you need to perform resistance measurements using a megger. A megger generates high voltage, which is capable of breaking down faults in the insulation. Failure to disconnect all equipment prior to megging could result in damage. To obtain accurate results, test all transmission lines and antennas separately. To begin, you need to connect the megger ground lead to the ground or shield of the transmission line. You would then connect the hot lead to the antenna connection or center conductor. At this point, you are ready to begin the test. You would now need to record your results on the Navc 9210.
Following the steps in the TDR job aid, first turn on your TDR. Ours is already on. Adjust the display controls for a clear, bright trace. Adjust the vertical position control to center the display. Line up the rise of the incident pulse on a vertical line. Connect your 6-foot length of RG58 cable to your TDR. Adjust the amplitude control to full screen display. Adjust the feet per division to see both the incident and the reflected pulse. We will now display the 4 different types of faults: a short, an open, a fray, and a crimp. Starting off with the short, as you can see, the line rises sharply. That indicates an open. That is the end of the cable. When you short the end of the cable, that rise turns to a dip. When you open it back up, it goes back to a rise. This is an open, and this is a short. As you can see on your screen, this is a frayed cable. Frayed cable shows up on the TDR as such. We're going to show you what a crimp looks like also. Notice how the crimp shows up right here. A crimp and a fray look very similar, except the only difference is the leading edge goes up on a fray, and the leading edge goes down on a crimp.
This is the Navc 9210/19. It is used to record your megger readings for your antennas and transmission lines. As a graph, it visually depicts changes in your antennas and transmission lines over time. To fill this in, you're going to want to write on the top the asset, unit, and antenna type. Here you want to fill in the dates you conducted your maintenance on. And on the left side, it goes by ohms and mega ohms. To fill in the graph, put a circle in the front of the box where your reading goes, and fill in the whole box. Over time, as the antenna or transmission line degrades, you will see your graph starts to go down. Once you conduct a repair, it'll go back up. In the bottom is the notes section. Here we wrote in our mega readings, which was greater than 200 mega ohms, which is open.
I'm Master Chief Kevin Eldridge, ET Rating Knowledge Manager. This video that you have seen is not intended to replace on-the-job experiences in the field. As always, refer to all technical documentation when performing this performance qualification. Thank you.